Hi, we're looking at question 23 now. This is a slightly longer question, but it focuses on ionic compound, which is year 9 topic, and cation and anion test, which is essentially under the branch of qualitative analysis. So let's dive into things. Whew. A slightly longer one today. Okay, so we start off with two formulas of ions. If you are to refer to your periodic table, you should be able to do this calcium ion question pretty well because calcium belongs to group 2, so that would mean the charge is 2 plus. However, for nitrate ion, you need to be able to recall because this is one of the polyatomic ion that you need to remember. Okay, there are a few anion. Anion refers to the one that's negatively charged. I'm going to write down all four of them. Sulfate. Okay, so we start with the first one: nitrate, hydroxide, sulfate, and carbonate. So if you were to follow my previous video, you will see me writing sulfate and carbonate as well. And there's only one positive one, and that would be ammonium ion. And that essentially is the first video that I recorded for the summer package, so please refer to that. Okay. Next, we're looking at a slightly longer mark question. Now, one of the key thing I want to focus on this year is actually how to guide students towards writing or descriptive question, like longer mark question like this, 4 and beyond. So when you are looking at this kind of question, don't dive into writing your answers immediately. Understand what is required of you. So if you see the command word explain, then you always need to ask yourself, why? Why is it like this? So in this case, why is the melting point high for calcium nitrate? And you need to discuss in both the structure as well as the bonding. So let's take a look at the answer. How I structure it is the same. Okay, so see, I focus on structure, and my first mark here, or my first point here, talks about describe the structure in calcium nitrate. The key word here is giant ionic lattice structure. So these four keywords together will get you the marks under structure. Okay, giant ionic lattice structure. If you have seen the diagram of like this cube-like structure, or your teacher have shown you in class, this is basically what this lattice looks like. This 3D cube. Yeah. Okay. So that's what ionic compound usually exists in. The structure usually look like this. Okay. Number 2, we need to talk about the bonding. So point 2 and 3, this one refers to the bonding in the answer. So what is the bonding like? What is ionic bonding? Ionic bonding refers to strong electrostatic forces of attraction between the oppositely charged ion. In this case, we have the two ions as being, as we wrote down in the beginning, the calcium and the nitrate ions. They are oppositely charged, and together they form this strong electrostatic forces of attraction. That is answering the bonding part. And then when we put them together, we need to answer towards so what? Why then, in this case, do they have high melting point? Because a large amount of energy is required to break the ionic bonds. So this is how you link up the 4 points to answer the high melting point. Okay, if you were to look at the right hand side, CE again refer to the common error that students tend to make. Anytime you mention about simple covalent bond or anything about covalent bonding, you get no marks here. The next one is, this is not a comparative question. We are not looking at something versus something, like we're not looking at calcium nitrate versus carbon dioxide, for example. So there is no need for you to compare. And when there's no need for you to compare, you use things like more energy is required or less energy is required, then you won't get marks as well. Okay, so go straight to the point. Just tell me that because of that strong bonding, then it results in large amount of energy. There is no comparison needed. Okay. Some students also miss out the structured part of the answer. That means basically the whole of M1 they did not write. Okay, but if you were to look at the question demand, they want you to discuss both structure and bonding. So if you have only talked about bonding without the structure, there is no way you can get 4 full marks as well. Okay, right. Next one is a little bit of balancing. If you would need a little bit of help in terms of balancing, then you will need to go to another video. I will link it at the bottom of my comment or my descriptor for this video, but I'm not going to discuss in depth over here. But this is essentially how this 1-mark question is going to be done. Okay, I want to look into the next one, which is a very high mark question, a 6-mark question, looking at 4 different salt solution, but in terms of cation, there's actually 2 types. Okay, and for anion, you can see is 1, 2, and 3. Okay, so the anion part, we like this: 3 types of anion, but 2 types of cation. Okay, so for cation, because it's calcium and sodium, essentially we can use flame tests. Okay, so we can conduct flame tests for each of the solution, and then flame tests. And then if it's sodium compound, it gives yellow flame. If it's calcium, it gives brick red or orange red. Okay, how I remember this is calcium because it belongs to group 2, so there is actually 2 colors linked to the flame. Okay, brick red or orange red. Whereas for sodium, it's just yellow, 1 word to represent it's from group 1. Okay, that's how I usually differentiate. But have your own ways, because every one of us remember things in a slightly different manner. Okay, next with the anion. The anion is very interesting because there are a total of 3 types of anion. And if I were to break it down, you'll see that these 2, bromide and chloride, they belong to the halide, which is group 7. So we can use silver nitrate to test for this. Okay, and for sulfate, we have to use barium nitrate to test for this. Okay, so we focus on the halide first. So for the anion that has halide test, basically the bromide and the chloride, how do we test? The most important thing, or rather the most common error students tend to make, is they forget to add acid to acidify. Okay, so why is this step required? So even if you look at my sulfate ion, I also need to add nitric acid to acidify. The reason for this is very simple. We want to remove any possibility of carbonate ion. Because if you were to learn about solubility rules, most of the carbonate are insoluble in water. Okay, so we want to eliminate all possibilities so that if any precipitate form, it would be only truly the one that we are testing and not because of potential carbonate ion in there. Okay, so always acidify first, followed by adding the testing reagent that you want. So for halide, we want to add silver nitrate. So if bromide is present, we get a cream precipitate. If chloride is present, we get a white precipitate. So that is 2 more marks added. And finally, for the sulfate ion, for anion, we always have to we need to acidify first. Nitric acid won't fail. Okay, it's it's a very possible acid to use because all nitrate ions, or rather all nitrate salts, are soluble. Okay, so followed by barium nitrate or barium chloride, both are fine in IGCSE. And if barium is present, barium ion is present, then we'll get a white PPT. Okay, so this is how we get our 6 marks. Oops. Again, before you write anything, always plan out your answer first. Look into what are the cations here and what are the anions there, and ask yourself, what are the testing method? Cation we can either use flame test, or we can add sodium hydroxide. But in this case, the flame test alone is good enough. Okay, and for the anion, because there are 3 main types, and out of the 3 main types, 2 of them belongs to group 7, so we use silver nitrate, and for sulfate, we use barium nitrate. Alright, so hopefully this has been helpful in helping you appreciate how do you answer ionic compound type of question, as well as the qualitative analysis, cation and anion. Alright, see you all for the next question, which is question 24, the final question.